Good afternoon, everyone. Great to see you. There's a few people here I haven't seen for ages, and I think they thought I disappeared from the kiwifruit industry, but I am still here, just hiding a bit down in Te Puke, where we're based at Plant and Food Research. So, breeding for resilience. But first, I thought, like the other speakers, I should explain who the Kiwifruit Breeding Centre is, or KBC. It wasn't just about adding another acronym to the industry, because I see we have quite a few as we've gone through all the speakers. So, as mentioned, we were established in October 2021, and it's a joint venture. We have two shareholders, Zespri and Plant and Food Research. Now, these two companies were running a brilliant breeding program before this. This is where Gold 3 came out of. We've heard about Gold 3 and its tolerance to PSA and the success it's been over the last 12 years. But the reason KBC was put together was because there's more competition. We've heard how successful the industry is. We need to keep ahead of things. You know, other people are trying to come in. So having a company that all we do, all the people in this company do, and you'll see soon how many there are, is focus on breeding. We have no other distractions while still having the support of those two big companies around us, Zespri and Plant and Food. So what are we here to do? Get more, better, cultivars faster. That's what we think about every day. How can we do that? And we'll talk about some of that as we go through this presentation. Our mission is to get cultivars that work right through the value chain. And we know, we're here talking about biosecurity. We know pests and diseases can be a challenge there, but there's also, it has to work for the consumer, it has to work for the markets. We have to get it to the markets in good quality, and it has to work on orchard. And so we're always trying to balance those three things. Of course, it would make no sense. It might be a fantastic tasting fruit, but if you can't get much yield on your orchard, that's not going to provide the returns needed for our growers. Just briefly, we do have a board. We are governed. We report to members that come from Zespri and Plant and Food, and we have an independent chair. So a bit more detail about us. We do run the world's biggest kiwifruit program, breeding program, which Plant and Food did as well, so nothing's changed there. We do have a commitment, though, to 5 years of rolling investment, which really helps us look to the future and commit to different activities that we think we need to do to get more better cultivars faster, around that 25 to 30 million a year. We have 60 permanent staff, and a lot of those came from Plant and Food. So we had all this expertise that understood the breeding program, but we have brought in new capability where we thought might complement that as well to achieve the things we think we need to. And then, of course, like the industry, we expand by about double through our seasonal activities. We're co-located in New Zealand with Plant and Food on their sites. And just notice that spread of where we are, because I will come back to that and how that's important in terms of understanding how our cultivars perform in different environments. In Italy, we are based with Zespri over there. And again, just remember that we're in Italy, because I'll have some examples of why that's important too around resilience. So all up, that's around 100 hectares of research orchards that we have, that we're monitoring vines on. And when you think that's mostly individual cultivars on there, it's a lot of monitoring for the team. So it's quite an extensive program. The last bit I just wanted to highlight here is when we are monitoring and evaluating these cultivars to see if they meet the targets that we need and have the performance, we do it naturally. You know, we're not applying bud break enhancers, agrochemicals. We're not doing optimised management techniques like girdling. We want to see naturally how do these plants perform. Anything after that, and it's a bit like the toolbox. Once you've commercialised, maybe then you can enhance it further. But we need to know these genetics will do most of the job, and then you improve upon that. Gold 3 is an example. It was tolerant to PSA, but you still need to manage it. You still need to do your management around controlling PSA, but it gave you that good certain step before you need to do the rest. So, breeding for resilience. And this session's about collaboration. And how do we collaborate specifically with our shareholders? We do have external parties we also do work with, but we really support each other. So we've got PFR, 1,000 people in that organisation looking at horticulture science. So they give us that fundamental science and technologies that we can drag into the breeding pipeline to help us achieve that more, better, faster. So we do a lot of research in partnership with Plant and Food. Then KBC, we're running the bulk of the breeding program. We're looking after the germplasm, the natural genetics, where we do our breeding from. We're doing the parental crosses. Then we move into what we call stage 1, which can at any time have 130,000 different cultivars, to evaluate those to see if they meet the targets we need. Then the most promising go through to stage 2, where we start replicating them up and putting them across different sites. And then out of about those 300, if we say, okay, we think these are meeting some of the targets Zespri want. Zespri, we think you should put these through to pre-commercial. Do you agree or not? And the Zespri board will then approve whether they go through for that final evaluation, which is essentially like commercial pilots before making a decision to commercialise. That bottom bit on this diagram is pretty important, and in some ways why the breeding program is so unique. We have really good insight and targets provided to us from Zespri through their consumer and market research work to say, what do you need to be aiming for? What's going on out there for any given product concept? And there may be a number of them that we're targeting at any one time. Takes a long time. So let's talk about resilience. So once we start doing parental crosses, it could take 25 years before there is a commercial product, because we're growing the vines. We need to grow the vines to then get the data, and you need data over a number of years to make sure you feel it's robust, to make decisions to go to the next stage. So anything we're crossing now, we need to be thinking ahead to say, well, if we want this yield, what pests and diseases might be there in that time, which is pretty difficult to do. As we said, there's a lot of unknown there, but we do need to be thinking ahead. And just thinking about that thinking ahead. I mean, when we started, we needed to put a strategy together, and one of our 7 strategic priorities is around being sustainability focused. And I think this really feeds into the resilience conversation we're here to do today. Our mission around this is to ensure long-term success and resilience for our kiwifruit industry. And we had 2 key priorities that came out. The one I'm going to talk about is breeding for the future, because that is the most important. It's about making sure that we're integrating mitigation and adaptation strategies into our breeding program so we are resilient. It's no good, and I know this isn't about pests and disease, but it's no good having yield that's going to work right now if in 20 years' time with climate change and warming, we couldn't get the same yield from that cultivar. So then I just want to go in a bit of detail on that, and I won't go through all these post-it notes, but we've got 2 outcomes. It's nature smart, and that's the adaptation side of the strategy, saying exactly what I just mentioned. We've got these targets, but how do we make sure they're really resilient into the future? Then there's the adaptation, the mitigation, which is nature smart. How do we make sure that we're developing cultivars that aren't going to be harmful to the environment, whatever that might be? So that might be that reduction in agrochemicals if we can have less reliance on those. And how could we actually contribute back or make sure with limited resources as we go into the future, whether that's less water or in sometimes too much water, how do we make sure these cultivars are going to be resilient? So it's working through all that. And a really important part I wanted to mention is that system smart down the side. We always talk about the female plant, it's the fruiting, it's what makes the money, I guess, but there's a whole system here that is really important for resilience. Let's talk about rootstocks, the foundation of the system. There's always been a focus on that, but we are amping that up. Waterlogging, top of mind in New Zealand, always been a challenge actually in other countries, but even drought might become a thing as well. There are rootstocks that could help with that. And then from a rootstock's point of view, can it transpose to the female scion some resistance or otherwise, which we don't want for a pest or disease? The other side is males as part of the system, so let's not forget those. Another plant that could get a pest or disease and actually needs to synchronise with the rest of the system. But imagine if we could have a self-pollinating female, so that wasn't such an issue. That could help with the resilience of that system into the future. So I want to give some more specific examples because that's all quite high level, and this is definitely not exclusive. I know you'll be looking at the list going, oh, well, that something else should be up there. But in the end too, you have to prioritise things also. But this is literally just a list as I was putting this together that came to my mind, top of my mind. Natural bud break, we heard about hydrogen cyanamide. So having cultivars that can have good bud break without relying on a bud break enhancer would be a great thing. And that leads on to removing that reliance, if we can, from the natural genetics on agrochemicals. Again, I like the toolbox idea. You know, you're always using different things, but if we can get so far with the genetics, that's really important. Tolerance to existing, and more difficultly, new pests and disease, because we know there's going to be different pests and disease as we see these changes climatically and in the environment. Tolerance to more challenging soil conditions, again, pretty top of mind at the moment. And this one's a bit more of a, I thought I'd just throw it in there. I mean, resilience is about consistency of a product as well. So consistency of quality attributes across environments. Sort of a side note, but something that's quite interesting, we can have full red flesh in New Zealand when we grow a cultivar. Take it to Italy, it's a starburst. So we believe it's temperature, but imagine if we could have stability of that colour regardless of the environment that it's growing in. And there'll be plenty of examples like that as well. So how do we make this happen? This is my last slide, and I'll just go through some of these. Some of these we are doing, some of them are in development. And one I see was just talked about gene editing. But I'll start first on the growing system side. So as I mentioned, we have to grow the plants. That's what takes that 25 years. Maybe there's different ways that we could grow these plants. Maybe it's vertical, so we can get more fruit faster, so then we can understand those cultivars quicker and come up and understand which ones are more resilient to different things or are achieving the targets we want. Rootstocks we've talked about. Evaluating in different environments. So remember that spread on that map of where we are in New Zealand. From modelling, it's been predicted that Te Puke will be like Kerikeri in temperature in about 30 years' time. So us evaluating cultivars in Kerikeri is really important for the Bay of Plenty, where most of our kiwi fruit is, for us to understand how they may perform. Another example is the Northern Hemisphere. So we have our stage 2 cultivars over in Italy. Italy has brown marmorated stink bug. So we can evaluate how those cultivars perform with that pest, you know, in case we ever need to understand that here in New Zealand. So that's all about growing, but one's about using technology. One's if we didn't have to grow it and we could understand the genes on certain things and to be more confident how a cultivar would perform. So genetic markers, I mean, we do use them. The one example I'm going to give is around males and females. We don't really want to plant out a whole lot of males. Sorry, we need a couple, but we don't need a whole lot in our 100 hectares. So when they're little seedlings, we can cut off a bit of the leaf and we can understand whether that plant is a male and female, and then we'll plant out the majority in females. Because imagine planting it out and then you had to get rid of 50% of that land. So that's an example, but there's potentially, when we understand genes on other things, we can do the same thing, whether it's related to pests and diseases or other attributes. Genomic selection is looking at a collection of traits and predicting what the outcome would be. This is in development, but is an exciting area as well. It adds robustness. So imagine if you could understand what the yield or the size would be before you even plant it out, so then you can make those decisions. And then we have gene editing. Yes, not allowed in New Zealand at the moment. But we do work with plant and food research to start understanding the traits and getting ourselves ready for that. I mean, there's examples from overseas where it has been used, and I'm sure many of you know what those are. There's one with rice, which is now resistant for bacteria blight. through gene editing, being able to target that gene to sort that out, I guess. Other ones is around yield. You can have increased yield in corn, they've discovered, by targeting a certain gene. There is a lot of understanding to do. Again, nothing's a magic silver bullet. You use different technologies when needed as well, so you wouldn't use just one of these on everything. But we are looking to understand that so we are ready to go, and it's pretty exciting. With gene editing, you can get there with natural breeding, just means it's faster, because you know what the gene is, you can target it, you can do it, and then you can plant it out. So thank you. That was pretty quick, but I hope you've got the feeling that we are very much focused into the future on resilience, and we're actually really excited about it too, and see our role in it is really important. Thank you.
Thank you, Jayne. Any questions online or from the floor?
Hi, Jayne. So what exactly are you doing to reduce your time frame from 25 years to 10?
So we have a breeding faster strategy. So a few of the things I mentioned is on the list and being prioritised. So there is the growing systems. Can we grow these plants differently, even just in the field, to get more fruit faster, which means more data, and then making decisions faster. And then we have all the precision breeding, which is another term you could use for gene editing, and then genomic selection. So that's a big part of it as well. So those are the key ones that we're looking at in that breeding faster. I mean, I guess imagine, especially from the genetic side and any of those techniques, stage one at the moment, we do individuals, because we don't understand, we have to plant them out and then get the data to understand, the outcomes. You have a sense of it, but you have to get the data to see. But if you had the confidence through knowing the genes, maybe you could miss that whole step. I mean, that's a while away, but we're really committed to shaving off that time. And actually another one I would mention is good decision making. There's technologies and tools and data and analysis, but making good decision making and being clear on what you need actually helps you move faster as well.